And greetings, BS Racheti, with again our favorite subjects, energy engineering for B mechanical, or sometime in some universities for third year mechanical engineering students. So last time we saw the what are we going to study in this next 4 to 5 classes about the cooling water requirements and cooling tower. These are the 2 points. And then environmental impact of thermal power plant. Accordingly, we saw just importance of cooling water, what is natural cooling, what do you mean by induced, what do you mean by forced draft, and then what are the environmental impact of thermal power plant. And we concluded, just I have given the brief about the cooling tower and environmental impact topics we are going to discuss in detail in the following classes. So let us start today with this cooling tower. So cooling water circuit we have seen. This is a boiler. This is the turbine, HP, IP, LP turbines. Then condenser. Then you will be seeing we are concentrating on this particular area today. So condenser, the exhaust steam coming out from the condenser is being condensed with the help of this cooling water circuit, which consists of hot CW pump, cooling towers, then cold CW pump. So hot water comes in from the top and while flowing down, falls on the fields, etc. There is a fan. The air rush from the bottom and enters upwards. So cold air come in contact with hot air. This heat transport takes place in the cooling tower, and the cold water is reused in condenser for cooling purpose. We have seen the importance of cooling tower. Main importance is we have seen the main function is to cool the steam which is coming out of condenser, and in view of more water requirement in power plant, cooling water plays an important role in reduction of water quantity by reuse of the cooling water circuit. This concept is very useful where water shortage exists. The method may differ. There are various methods which we are going to study in detail, but the principle is same. That is to cool the waters and hot air flowing towards the atmosphere through the chimney. Okay, in the upward direction, you can say. Most of the cooling towers use evaporative cooling system that evaporates small droplets of pure water that give no such harm. However, there is a loss of liquid droplets. So when the cooling taking place in the cooling tower, the hot air goes upwards in the atmosphere through the tower, you can say, which may affect the environment badly because it contains some chemicals carries some chemicals along with which is along in the water, so that may damage the environment. So now this this problem has also been solved by using drip eliminators. This drip eliminator not only prevent them from damaging the environment, but also save water by recycling it. Means these drip eliminators now, what they do, they are placed in the hot water patches so that water droplets are being eliminated or collected or captured and fallen down into the cooling tower. So then that is the reuse of the cooling water takes place. From here, we'll start with this slideshow. Different parts of cooling tower, and just this is the general layout of a cooling tower. This is not exact one. Such type of cooling towers we have seen in air conditioning system of a building, central building. If you are doing this air cooling, then such type of cooling towers are being used. For our study purpose, just what are the different parts in the cooling tower. Methods may be different, types may be different, but the components are almost same. So with help of this diagram, I wanted want to explain the different types of cooling tower as general eliminators. So this first we'll see, just show this is the at the top of the, this is the cooling tower made of the concrete or fabric, you can say PVC or polyester fiber. Then that top fan is placed, and which is run with the help of motors. We'll see the water header, sprinkler nozzles are there. Then we will be seeing this PVC fields below this water nozzles. Then there is a mesh to, so as to uh, collect the debris or dust particles from the air. Then you'll be seeing this inlet of header of water, which is coming from the condenser, goes through this header, and then it follows through subheaders and falls down. This is carrying hot water. Now this is the cold water after cooling. This is the bleed wall. The drain is there. If you want to drain the flush the tower or flush the tank sump, you can drain the water. This is the outlet. Okay, then makeup water is required in view of evaporation of water taking place along with and goes along with the air. So some makeup water line is being there. Okay, and this is the air inlet. Through this air inlet, when the air going upwards due to this fan, a vacuum is being created. So air, lower density, flows in the upward direction, while flowing, it comes in contact with the hot water, and this hot water gets cooled and falls down on the fields. So the function of the fields is to give more surface area contact with air and water, so as heat exchange takes place, more heat exchange takes place in the filling PVC fields, and then water droplets get cooled and collected into the sump, and from the outlet it is being sent to the condenser for a reuse and cooling purpose, cooling of the steam. So this is in brief about the working I also told, and what are the components. So see here the components. Eliminator, it allows, means it takes the droplets, and droplets are dropped falling into the sump. Spray nozzle means, which as we saw, that it also prevents the damage of environment. PVC filling, not falling, PVC filling, it reduces the falling speed of hot water. It is meant for more surface area of contact of hot air with air entering from atmosphere, so that almost all the water gets cooled before falling in the some cooling pond, and water can be reused for cooling. Float wall, this float wall is not in the bigger cooling towers. It is just in the, I just told, in the air conditioning system. See, this float wall, it maintains the water level inside the sump. Bleed wall is to control the, if there is some chemicals concentration increases, through this bleed wall you can drain the these minerals like that. Body is the outer surface of cooling tower, often made of FRP, smaller one. And if you go for higher cooling towers and higher capacity, then they are of concrete, which protects the internal parts of the cooling tower. So this is in brief about the different parts of cooling tower. Now we'll see the cooling tower specifications or requirement of cooling tower. What are the requirements of the cooling tower? Cooling water specifications. While design and selection of cooling tower, following points must be considered: type of cooling tower, forced cooling tower, induced cooling tower, and natural draft cooling tower. So these three are we going to study in detail in the later class. So what is forced cooling draft? Uses a fan at the bottom. Induced draft cooling uses a fan at the top, and natural draft uses no fan. So the basic principle is same, but only fan, the position of the fan at bottom, forced draft, position of fan at top, it is induced draft, no fan, it is a natural draft cooling tower. So how they work, they will see later on. Design of cooling water, second concept, second requirement or second specification. So whether it will be cross flow or counter flow. In cross flow, the hot air, hot water mixes with air at 90-degree angle in vertical plane. low pressure drop, and low power consumption. That is the cross flow benefits. Counter flow, water flowing from the top. Just we saw in the last figure, water was falling from the top and air entering from bottom and mixing in vertical plane. So then third requirement is motor power. The rating of the motor used to drive the fan in the cooling tower depending upon the capacity of the uh, you can say heat exchange. Cooling capacity, this is also related with the same, the rated volume of air that is to be moved in through the cooling tower in a given time. It is rated in tons per hour, like that. So cooling capacity is to be also one of the requirement or specifications of the cooling tower while you are doing the project or constructing new plant. You have to consider these points. Then flow rate, the flow rate of cooling water through the tower given during a given time. Tower flow rates vary as a function of size of cooling capacity. Means now once I had told or will that condenser, there is a cooling water requirement of 27,000 meter cube per hour into 10 megawatt plant when I work, and also work in 250 megawatt where is the cooling flow rate is 33,000 meter cube per hour of water requirement. So this is depend upon the capacity, means 210, 250, 500 megawatt. So like that, this flow rate may vary. Sump and basin capacity. So cooling, after cooling, the capacity of the water to collect at the bottom in the cooling tower, uh, cool water is collected. Each system has a basin specifically designed to meet the needs of the plant. Operating weight, the total operating weight of the cooling tower should be used to determine whether the tower should be placed. For instance, the operating weight cannot exceed the rated load of the roof it will sit on. Supply voltage and phase type used by fan motor, AC or DC. Supply phase, single or three-phase supply. Construction material, fiberglass reinforced polyester for, I told, smaller capacity to avoid corrosion, or PVC, metal, wood for construction of cooling tower, and also concrete you can add in that. So these are the cooling tower specifications: type of cooling tower, design of cooling tower, motor power, cooling capacity, flow rate, sump basin capacity, the operating weight, supply voltage, supply phase, construction material. Most of the things I'm telling with the practical approach, as I had worked for 31 years in the thermal power plant. Now we'll see general types of cooling tower: natural draft cooling tower, forced draft cooling tower, and induced draft cooling tower. So what is the natural cooling tower, which is mostly in the nowadays common in 250 and above megawatt thermal power plants, or means you can say in modern power plants. And I have worked here also in this 250 megawatt and have also done the maintenance activities of this cooling tower. We call it as generally NDCT. So natural draft cooling tower. So what are they? So what is this shape? If hyperbolic shape, and drift eliminator is there, nozzles are there. You have seen the working of, same working will be there, only just construction differs. So fills are placed below these nozzles, water nozzles, and then there is a open space below the fills, and at the bottom basin. Fills are made of this polypropylene or plastic like this. They are placed in the bunches in number. They are in ample number. So whenever the water falls inside the over these fills, the hot air comes in direct contact with this water, so that heat exchange takes place. And due to the shape, hyperbolic shape, the low density air rush upwards and flows along with the water droplets, and these water droplets are get eliminated in the drift eliminator and falls down again in the tower, and the hot humid air goes to the atmosphere. So this is the working principle of natural cooling tower. Then hot air moves through the tower, fresh cool air is drawn into the tower from bottom, no fan is required, so automatically the auxiliary consumption is very much less maintenance. Concrete tower less than 200 meters. So this is in general C. Here, this cooling tower is look like this. So opening space is there. Inside these are the fills somewhere here. Then above that fills there are nozzles, means water header. How the water headers are there, we'll see in the next picture. Then above that, drip eliminators are there. So this is about the natural cooling tower. Advantages: it is operating and maintenance costs are very less compared to other, and no fans are needed. It creates its own draft, assuring efficient operation even when there is no wind, longer life. Disadvantage is the seasonal higher capital cost, and performance varies with the seasonal changes. Why higher capital cost? Because the draft which is to be created inside this cooling tower is only due to the shape. So shape should be such that the height and all this venturi should be such that it will be of higher side, higher length, width, then automatically cost increases. Next, we'll see this natural cooling towers in 250 megawatt. I just shown the now how the inside. These are the water headers, either of cement concrete or the metal nozzles are you are seeing in the upward direction. So when the water comes from the condenser to the cooling tower, they first come in the main header, and then they are divided into subheaders, and in the subheaders the nozzles are being placed. And when water because the water is coming with pressure, the water flows out of the nozzles and falls on these fields. These fields are some different type here shown here. Actually they are of I where worked was polypropylene or plastic type, you can material say here, that I am showing here. So this here you are seeing the nozzles are at the bottom side, here the nozzles are seen at the top side. So when fields are there, means below these nozzles, and so that sprinklers and hot cold water is coming from the bottom, and while flowing upward in the direction that come in contact with this water spray, and all the water particle almost gets cooled and fall in the sump. Fill type is, now this is practical approach, which where of 250 megawatt double edge porcelain cross fluted film material type material. It is PVC UV regions also called. Full height is fill height is 1.2 meter. Distribution pipe asbestos or cement material is class 10. Size 200 mm, having loose prefabricated holes for nozzles. The size of the you can say pipe header or a pipe's diameter is 200 mm. Sorry, down spray. So nozzle types are down spray. I have shown up spray and down spray also. One down spray in where we work in 250 megawatt. Material of this nozzles is polypropylene, and life is about 10 years. So this is the cooling tower actual of natural draft cooling up to 50 megawatt. Some dimensions I'm having, you will not find anywhere in the books. Maximum diameter sill at the top 104, means above the sill you can see here. That means the maximum diameter is 104 meter. Diameter ring at bottom near fills you can say 99.10 meters. Diameter at throat level it is 59.27 meters. Diameter at top is again increases 62.73 meters. And three level means the venturi level, means where it is the narrow one. It is from the base you will be saying 101.25 meters, and total length of the shell is 135 meter from the ground to top, you can say. So that was the height. Okay, this is about the dimensions, material actual. So now next we're going to see forced draft cooling tower. Air is blown through the tower by centrifugal fan at airborne bottom. You are seeing these fans are placed at the bottom, so that when the fan operates, and you will see the height also is less than compared to natural draft, because the air is forced through this atmosphere, through the fan from the atmosphere to the cooling tower. So air blown through the tower by centrifugal at air bottom or air inlet, advantage suited for higher resistance, and fans are relatively quiet. Disadvantage, recirculation due to high air entry and low exit velocities. Auxiliary consumption is more. These are the disadvantages. So what happens? This high velocity due to the fans, high velocity of air at bottom is high, and then when it is flows upwards, the velocity is low. So and again the difference between high and low, this low velocity again will become coming towards the bottom. So the recirculation of the air may be taking place, which will affect on the performance of the tower. So the components you are seeing, just a line diagram I am showing again. You can draw in the examination like this also. Hot water, this is the hot air outlet. Then these are the packings or fields, you can say. Then hot water from condenser flowing down through the nozzles. FD plan is placed at the bottom, and air is entering inside this and flowing out, and the cold water which is falling down is collected into the cooling pond, and from pond or sump it is then sent to the condenser. Principle of working is same, only the construction parts differ. Now IDCT, that is industrial draft cooling tower in 210 megawatt plant, again where I worked in 210 and 250. So there is some difference between. So in 210 megawatt there are 10 cells like this of cooling tower, each having one fan, 3 to 5 blades, nozzle set, gearbox, motor to drive fan, lubrication system for gearbox, rigid coupling set for motor and coupling, hub set for holding the fan blades. To hold this fan, this hub is there, the hub set for fan blades, cooling pond with strainers at the bottom, cooling pond, and when it is going to the condenser, there are strainers placed between at the outlet. Risers, hot water. So there are two risers, one from the left side and or the right side, to get the hot water into this header. Preventive maintenance, nozzle cleaning, cooling pond strainers cleaning, gearbox oil top up, breakdown shutdown was blade alignment, blade replacement, vibration reducing by alignment, etc. And blade angle also can be adjusted with the help of blade angle adjustment. Vibrations gets reduced, and performance of the cooling tower can be also increased. So these are the practical approaches in the 210 megawatt plant we were doing. So will not find in every. So induced draft cooling tower in 210 practical approach, two types: cross flow, counter flow. I work in the counter flow type of induced draft. Advantages: less circulation, recirculation than forced draft, because there is no question of recirculation as the board fan is at the top. Higher vacuum can be maintained in the condenser. Disadvantage: fan and motor drive mechanism require waterproof covering. Maintenance cost is high. Breakdown of city fans affect the loadability of the plant. Means the plant has to reduce the load if the more than one or two city fans gets filled. Capital cost is high. Risk factor more while working. Seasonal impact on working: if the cloudy atmosphere is there, the performance of the cooling tower reduces, and higher auxiliary consumptions due to this motors set. So actual scene like this, here only seen your 4 plus 6, so 10 cells of the compromises of total one cooling tower system. So the 10 cooling towers or mini cooling towers, and each having just shown in the earlier case that having all the fields and you can say eliminators, so that water falling down. Here you can see at the bottom is cooling tower. This is also cooling tower, sit cooling pond, you can see. Every time we have to clean, because most dust and scale sludge is being accumulated in the cooling tower, which again affects the performance of cooling towers. Okay, and that water then goes to condenser, back to condenser with the help of pumps. Water enters top. So there are two types: cross flow and we have seen the when water in cross flow, water flows in from the up and air comes all around the periphery of the, and like this we have shown here. So air from the all sides of the periphery comes and flows upward direction, and ID fan is there and in the top of the cooling tower. And cold hot water when flowing through this header, the water sprays through the nozzles and falling in the fills and packaging, you can say. Then these are the drip eliminators, which eliminates the droplets flowing while flowing with along with hot air, and the water gets cooled and taken into the sump, and this cooled water is taken to the condenser with the help of pump. Then last one, counterflow induced draft cooling tower, which I explained, and we have worked on this type of cooling tower. Water enters top and passes over the fields. Air enters from the bottom side and leaves from the top. Induced draft and draws air around the fill. So around the when it is going, the counter means opposite. So air from the bottom goes in the vertical plane like this, and hot water from the top to bottom in the again vertically falling down, collecting into the collection basin or cooling pond, and then cold water is taken to the condenser again. So this is in brief about the types of specification of cooling tower parts we have seen, different parts and types of cooling towers we have seen in this class. Okay, let us study the little more about the cooling tower in the class number 2. Till then, we'll stop here. Thank you very much.